Okay, in this video we're going to discuss the range restrictions on cosine, inverse cosine function and the inverse tangent function. First, the inverse cosine function. Of course, we're talking about a parent function, not really a parent function, but the originating function, or the inverse function of inverse cosine is y equals cosine x. When we determine the inverse function, we get y equals the inverse cosine of x. Remember, over here, x is an angle, y is a number, but over here, x is a number, and y is an angle measure. Okay, so let's graph both of these on the same axes. Yeah, let's go here. Let's do the best I can. Let's try to make some straight lines. And let's go with green. Cosine looks sort of like this. Okay, this is out at 2 pi. This is at pi. That's that trough point, lowest point. The crosses the midline at 3 pi over 2 over here and pi over 2 over here, and is 0 at the y-axis, or the origin. The inverse function will reflect about the function y equals x, and so my inverse function, and I haven't drawn this one in a little while, but it's going to look something like this. Okay, it's not nearly, it should be the exact same. I'm doing the best I can. Actually, let's try that again. Let's do that. Okay, that's a little better. And it continues on and does this kind of thing. And of course, like in the previous video about sine, it doesn't pass the vertical line test, so it's not a function. And so what the old man in sandals had to do was restrict its range, and they did the restriction from here to here. And so this is the range of our function, and our domain goes from -1 to 1, and our range goes from 0, that's this 0, up to pi. And because this point corresponds with that, 0, and this value is at the trough here, it goes to pi. So on the unit circle, that looks like this. That looks something like this. That's poorly done, but it's good enough. And so the inverse cosine function goes from 0 to pi, so it's here. And as a point of review, sine's range restriction was from here to here, the right hemisphere. So cosine is 0 to pi, and sine is -pi over 2 to pi over 2. So same reasons, same thing. Now let's talk about tangent, and then we can get you out of this video, I think. So y equals tangent x, and then its inverse is y equals the inverse tangent of x. And again, this is a number, this is an angle measure, and this is an angle measure, and this is just a number. Okay, so you need to keep those things in kind of in your head, or else it's going to get confusing very, very quickly. So let's put some axes down. We have some different colors, so I'm going to try to accommodate that. And let's go this with the x-axis. And my tangent function, recall, looks something like this, with these asymptotes that occur at pi over 2 and -pi over 2. And this is at 0, the origin. And then I have another one of these guys, and another asymptote, and another one of these guys, another asymptote, another one of these guys, and an asymptote. Then it continues on to the left in the same manner as well. So when I graph the inverse, I end up doing this, and then of course there's an asymptote there, and then it goes like this, and there's an asymptote here, and it goes like this. And so I reflected again about the y equals x function. But what happens is we get this doesn't pass the vertical line test because it crosses there and crosses there. So this one was significantly more clear exactly what to do, no debate. We're going to eliminate this curve and eliminate this curve so that our tangent function is defined to be in between pi over 2 and, or x, and negative pi over 2 and pi over 2. And so if I summarize the three inverse functions on the unit circle, so it just gives you a visual of how the inverse functions are restricted in the range. It looks something like this. That's a little bit of a better circle. And so let's say that y equals the inverse sine of x. Sine is restricted from, I guess I should have chose a different color. It's hard to see against that white, but maybe that's okay. So inverse sine is there. Inverse cosine are all of these values. We'll darken that in so we can still see the yellow. And inverse tangent is much like sine. It's this right hemisphere. Okay? So I can only get, so an example of a problem that we would get, if you're not in my class, then you can skip, but maybe this will help. One of the common problems I think I've seen a student actually asked about it was, if I'm given this and the problem generally asks basically, that's what she was telling me. That's no. So a problem that is common, and if you're not in my class, you don't have to pay attention, or maybe you can learn something from it anyway, is if I get, I think the problem asks this, 3 pi over 4, or 7 pi over 4, equals the inverse sine of x. And so remember, again, if I'm talking about inverse sine, this is a number, and it's going to tell me an angle that generates that number. And the question asks, is this a legitimate answer or outcome of taking the inverse sine of some number? And you should think sine gives me those values from negative pi over 2 to pi over 2. These values in between here on the unit circle. And where does 3 pi over 4 exist? Well, 3 pi over 4 is this angle, initial side, terminal side. It's that angle, 3 pi over 4. So no, inverse sine will never give me this value. Can't happen. Because inverse sine will only give me values between negative pi over 2 and pi over 2. And this is outside of that. So that's the kind of thing that the kind of question, or at least a kind of question that can be asked of you to determine if you understand what the range restrictions are on these inverse functions. All right? Hope that helps. Take care. Bye.